Namaskar. Welcome to the KTHM College Nasik and welcome back again to the lecture series of Mathematical Methods in Physics. In this lecture, we are going to start the new model, partial differentiation. Differentiation is the mathematical process to determination that how the function is changing with respect to the variables. As we know that in physics there are so many physical quantities, and some of physical quantities are depend on any other physical quantities. For example, velocity. Velocity is nothing but the rate of change of displacement with respect to time. So here displacement is depend on time, or velocity is depend on displacement. Acceleration is the rate of change of velocity with respect to time. So here velocity is changing with respect to time. So we will get acceleration. And there are so many physical quantities. So we can write velocity v is equal to dx by dt, where x is a function and depend on t is a variable. So I can write here x is a function and t is a variable. Similarly, acceleration we can write dv by dt. So here v is the function and t is the variable. So this process is to determine the velocity and acceleration. So I can write x is a function of t. Here t is variable. V is a function of t, so you will get acceleration. Similarly, there are so many physical quantities which are depend on any other physical quantities. So I can write in general f is the function of t or any other physical quantity instead of t. So f is the function of t, where t is the variable, and the differentiation, and in differentiation if function is depend on only one variable, here t, then this is the differentiation. Now let me introduce partial differentiation. The function or physical quantity which are depend on two or more physical quantities. So here we use a partial differentiation for doing the mathematical process. For example, if you consider a cylinder having height h and radius r, then the volume of the cylinder is equal to pi r square h. So volume of the cylinder is a function which is depend on radius of the cylinder and height of the cylinder, because volume changes if height changes and volume changes if r changes. So if function is depend on two or more variables, then this process of differentiation we use by solving partial differentiation. So how to do the partial differentiation? If function is changing with respect to two quantities or two variables, and if these variables are independent variables, because r is not changing, it is independent. So r and h are independent variable, because r and h are not depend on any other physical quantities. Here v is changing with respect to r by keeping h constant. If we increase the r, volume of the cylinder increases although height is constant, or if we increase the height, volume of the cylinder is changing although r is constant. So partial differentiation is used here. Change in volume with respect to r by keeping h constant, and changing volume with respect to h by keeping r constant. So if physical quantity or a function is a variable or variable of two or more variables, then partial differentiation is the rate of change of function dv. I'm sorry, we can call it dabba v by dabba r by keeping constant h. So here volume is changing with respect to r by keeping constant h, and dabba v by dabba h by keeping constant r. Now if you consider a gas cylinder containing a gas, if you consider a cylinder and it contains gas molecules, okay, so the pressure is a physical quantity, and this pressure of this gas cylinder is changing or depend on volume. If we decrease the volume of cylinder, the gaseous pressure increases. So pressure is depend on volume, and if we keep volume constant and if we increase the temperature of the system, pressure also increases. So here pressure is function of, we can write pressure is the function of volume and temperature. So partial differentiation we use here by keeping one variable constant. Now if you consider a metal plate of area A and its thickness x, and area A, and if we give heat to the one end of this plate, then the thermal conductivity Q is equal to Ka theta 1 minus theta 2 upon x into T, where K is the constant, A is the area of the plate, theta 1 and theta 2 are the temperature difference between these two ends, x is the thickness and T is the time. So here Q is the function of A, x, theta and time. These are the variables, and Q is the, so here also we can use partial differentiation by finding the thermal conductivity, rate of change of heat flowing through this metal plate dq with respect to either A by keeping constant these, with respect to x by keeping constant others, and so on. One more example, if you consider a wire, conducting wire, if you consider two wire, let's say this is a copper wire and this is the aluminum wire. The copper is good conductor and its conductivity is better than the aluminum wire. So if the copper is a good conductor and its conductivity is higher than the aluminum wire, it means that it has resistance. So resistance, we know that resistance is equal to rho L up pi r square, where rho is the constant, L is the length of wire and r is the radius of the wire. Okay, so here resistance is depend on length and r. If we increase the length, resistance increases, but if we increase the radius, resistance decreases. So r is the function of L and r, and with the help of partial differentiation we find out the resistance, rate of change of resistance with respect to both the variables. So finally we can write in general f is the function of, if f is the function of x and y, then the partial differentiation we use here for differentiation dabba f by dabba x, we can obtain this term. Just simply differentiate this function with respect to x and dabba f by dabba y. Remember, d by dx or d by dt we use for differentiation when the function is depend on only one variable. But if function is depend on two or more variables, we use a partial differentiation, and for that we use the symbol daba, right? Let's take a problem. If f is the function of x and y, and which is given by, the function is given here, x square plus 2xy, any function, plus y square. So in this case, f is depend on x, y, y. If x changes, function changes. If y changes, function also changes. So x, y, these are the variables. So we can obtain daba f by daba x. So we know that how to solve the partial differentiation. Differentiate the function with respect to one variable by keeping constant others. Okay. So daba f by daba x, we can first differentiate this function with respect to x. Simply do the differentiation, x square differentiation 2x plus keep the constant y and differentiate with respect to x. So we will have 2y. And the differentiation of y square constant term is 0, so no need to write it. Now the differentiation of f with respect to y by keeping constant x, this x is constant, so its differentiation is 0, and in this case y differentiate y, so we will have 2x only. So 2x plus differentiate this y with respect to differentiate this function, so 2y. So in this case, daba f by daba x and daba f by daba y both are equal. That means function is depend on two variables and changing with two variables. Similarly, one more example. If f is the function of x and y, and which is having x cube plus xy plus y cube. So daba f by daba x, we can find out 3x square plus y, and this is the constant and its differentiation is 0. Similarly, differentiate this function with respect to y. So daba f by daba y, we can write here, this is the constant 0, and here x plus 2y square. I'm sorry, 3y square. Okay. How easy it is. So daba f by daba x, we can also write daba f by daba x is fx. That means f is the function of x, and daba f by daba y, we can write fy, where f is the function of y and f is differentiate, or f is changing with respect to y, f is changing with respect to x. Now the next topic is successive differentiation. Very simple it is. If f is the function of x and y, so we know that its partial differentiation is fx. We can write daba f by daba x by keeping constant y, and fy we can write daba f by daba y by keeping constant x. Okay, so if daba f by daba x and daba f by daba y, daba f by daba x, if daba f by daba x is also the function of x and y, although we differentiate with respect to x and function with respect to y, again this quantity or this function is also the function of x and y, then we differentiate it daba by daba x, this function, so we will get daba square f upon daba x square, and we can write it f x x. That means f is the function of x, this, and this fx is also the function of, this is fx, right? So this fx is also the function of x. Similarly here, dabba by dabba y and dabba f by dabba x. So here we can write dabba square f upon dabba y and dabba x, and we can write this term as f x y, where f is the function of x, f is the function of x, fx, and this fx is also the function of y. So fxy. Similarly, fy, if dabba f by dabba y is again function of x and y, and again if we do the partial differentiation, differentiate these fy with respect to x, fy, or we can write dabba by dabba x, dabba square, dabba f by dabba y, and this fy is again the function of y. So I can write here dabba by dabba y, dabba f by dabba y. Finally we can write dabba square f upon dabba x, dabba y. This is called as mixed partial differentiation, and dabba square f upon dabba y square. So if we can write this term f y, this term fy is the function of x, and here we can write fy is the function of y. So this is the second order partial differentiation. Similarly, if fxx is again the function of x, so we can write fxxx, xx, and so on. If fyx is again the function of x, so we can write fyxx, or if fyy is again the function of x, fyyx. This is the third order partial differentiation, fourth order partial differentiation. Example: find first and second order partial differentiation, PD in short form. For example, if f is the function of x and y and given by 2x cube y plus y cube, the function is given by 2x cube y square plus y cube. Okay, so find the first order differential equation. First find out fx, that means dabba f by dabba x, function depend on x. So very simple differentiation, just differentiate with respect to x. 3 into 2, 6x square. Y square is constant forever, and the constant differentiation is 0. Alright, now fy, differentiate this function with respect to y. Very simple it is. 2x cube constant as it is, and again differentiate with respect to y, so 2y. So here I can write 4y, and this constant plus 3y square. Now differentiate. Now fx is also the function of mxy, so we can find out fx is also the function of, so differentiate with respect to x, this fx. So that means we can find out here fxx. Again differentiate this fx with respect to x, so we'll have 12x y square. Okay, and we can find out fyy. This fy differentiate with respect to y, so here we'll have 4x cube plus 6y. Now we can find out mixed differential equation. Fx is the function of y. So differentiate this fx with respect to y. So we'll have 6 into 2, 12. X square as it is and y as it is. Similarly, we can find out fyx. So fy is function of x. So the fy differentiate with respect to x. 12x square y. Okay, and we are differentiating this fy with respect to x. So y is constant term. This, so no need to differentiate it. Right? Now the next point is total differentiation. In total differentiation, if f is the function of two variables x and y, but the function is changing with respect to x and y simultaneously, so that time we have to use total differentiation to obtain the differentiation. So the formula for that, if f is the function of x and y, right, and the function is both depend on both variables or changing with respect to x and y simultaneously, so that time we use a total differentiation denoted by df, which is equal to, again use partial differentiation, dabba f by dabba x dx plus dabba f by dabba y dy. The simple proof that I have given in your textbook, you can go and use. So if you take an example, if f is the function of x and y, and which is given by x cube plus 3xy plus y square, whatever it is. So total differentiation df, if you want to obtain the total differentiation of given function which is depend on x and y, and the function is given x cube plus 3xy plus y square, so differentiate, total differentiation, we can write the formula dabba f by dabba x dx plus dabba f by dabba y dy. Remember, this is dabba and this is d. Okay, so differentiate, first obtain dabba f by dabba x, differentiate this function with respect to x. So we'll have 3x square plus differentiate total with respect to x plus 3y, and this is the constant 0. Okay, keep dx as it is plus, now differentiate the function with respect to y. So this is constant 0, and here we have 3x, okay, and plus 2y. Keep dy constant. So this is the total differentiation. One more problem, if f is the function of x and y, and the function is given by y e raised to x square. Now f is the function of y and x, or x and y. So total differentiation can be obtained by differentiating dabba f by dabba x dx plus dabba f by dabba y dy. So differentiate this function with respect to x. We know how to differentiate this function partially. Keep constant one variable and differentiate the function with the other variable. So differentiate this function with respect to x, this function with respect to x, this function. So y is constant, okay, keep it as it is. And what is the differentiation of e raised to x? E raised to x. But 2x is the differentiation. So we can write 2x or 2yx or whatever it is. 2x and e raised to x square dx plus. Now differentiate this function with respect to y. Okay. So differentiation, this is the constant as it is, e raised to x square dy. So this is the total differentiation of the given function. I hope it is clear. One more problem. If f is the function of x and y and the function is given by x raised to y. So total differentiation, write the formula dA by f by dA by x dx plus dA by f by dA by y. Whenever you will get the chance to write the formula, just rewrite down it. dy. Okay. So differentiate this function with respect to x by keeping y constant. So therefore dA by dA by x raised to y dx plus dA by dA by y x raised to y dy. Let's differentiate x raised to y with respect to x. We know that yes, y x raised to y minus 1 dx is constant. Now plus differentiate this term with respect to y. We know that differentiation of a raised to x is nothing but a raised to x log a. So use here this formula. So I can write here x raised to y log of x into dy. One more problem. If u is the function of x and y and which is given by e raised to x cos y, then show that dA by square u upon dA by x dA by y is equal to dA by square u upon dA by y dA by x. So first find out dA by square u upon dA by x dA by y. So for that we have to find out first dA by u by dA by x. Okay. So first dA by u by dA by x. Differentiate u with respect to x. So I can write here e raised to x cos y as it is. Now again differentiate with respect to y. So we'll have dA by square u upon dA by y dA by x. So we'll get this term. Okay. So this function dA by u by dA by x is differentiate with respect to y. So we'll have minus e raised to x sin y. Now differentiate u with respect to y, dA by u by dA by y. So we'll have minus e raised to x sin y, and differentiate this u with respect to x, this term, this f ui, differentiate with respect to dA by square u upon dA by x dA by y. Now differentiate this u with respect to x. So here minus e raised to x sin y. So here I can show that dA by square u upon dA by y x, dA by square u upon dA by x dA by y, both are equal, hence proved. So similarly there are so many problems in your textbook. You can go through your textbook and try to solve this differentiation, and we'll see you in the next class. Thank you very much.